minimum operations to convert number. So we are just giving numbers array, so there will be integers inside, and yeah, we can check the integer. So the nums I should be more than or equal to minus 10 to the power of 9 and less than or equal to 10 to the power of 9. And the nums length is 1000, and the start should be more than or equal to 0 and less than or equal to 1000. Start not equal to go, and all the integers in nums are distinct. Yeah, and if we check all those distinct, and we just want to check from the start to go to the goal, and we have this kind of operations for each of the steps. So for number x, so x is just starting from this start. So for example, we are starting with 2, and we can use different operations. We can plus nums I or minus nums I or XOR nums I. So we want to return the minimum number of operations needed to convert x equal to start into go. Yeah, so this is a typical BFS problem. We just need to use this kind of operations, and each of them will cost 1 step. So by using BFS, we can definitely find the final answer. So as this x is controlled to 1000, so we just need to control where we need to put it inside of the queue, because operations that set x to be out of the range, so if it is out of the range, so yeah, they are valid. So if it is set out of the range are valid, but no more operations can be done afterwards. So this means if there is a value x out of this range, maybe more than 1000, so they are still valid, but we cannot do the further operation. Yeah. So let's try to write a BFS for the problem. So we need a queue and we need a set. So let me use a weighted set. So the queue would be the queue, and inside we need the start. This is the position where we want to start, or this is the number where we want to start. And we also need a step. It's starting from 0. And we also need a weighted set. So it's going to be a set inside. It's going to be the start. Now we can check the queue. So while queue, we can pop it out. So we have an x. So x is our position, and the step, we're going to pop it out. Yeah, should be equal to q dot pop left. Now we can check the values of this x. Yeah. So if this x equal to the goal, we can return the steps immediately. So this is our step. Yeah. But what if this x is more than 1000, or this x is less than 0? Yeah. So this means we're gonna continue. We will not check it. Yeah, because if it is out of this range, it is valid. It means we get an x. It is valid, but we cannot do further operations. So this means we're gonna have a continue. We will not do the operations. So basically, we will not put it inside the queue. Yeah. Now, what is gonna happen? So as we popped this x out of the queue, we have this kind of operations. So we're gonna have a record. So I'm gonna use a plus, should equal to x plus nums I. Yeah, and I will use a minus. So minus should equal to x minus nums I. And another operation I'm gonna call it XOR, gonna be x with XOR of nums I. So I have 3 different numbers. So I'm gonna call it plus, minus, and XOR. So I'm gonna check the values for the BFS. So for so this I will call it y. So for y in those kind of values, so it's gonna be plus, minus, and XOR. So if y not inside the weighted, yeah, so y is those kind of 3 values. So the weighted set gonna add this y, and similarly for the q. So q should append with this y, this number, and the step would plus equal to 1. As you can see, this is the entire code. If we didn't find a solution, we're gonna return -1. Yeah, you can see from here and return -1 if it is not possible. So basically, this is the entire code. We just need to prepare queue and weighted set, and we can run the BFS. We're gonna check the queue, and we're gonna take it out. If it is equal to the goal, we're gonna return the step. The step is starting from 0, and if it is out of the range, we will continue. We will not do it, and then we're gonna create different kind of operations, and then we're gonna check the neighbors. The neighbors is 3 different kind of operations. If it is not in weighted set, we're gonna put it inside and close to the append. Yeah. Now let me run it to check. Yeah, because I didn't prepare the nums I, so yeah, because I don't know how many numbers inside the nums, so let me just use a for loop. So for I in range length of nums, and we're gonna have 3 different operations. We're gonna have a plus, minus, and XOR, and then we're gonna check. So we're gonna use another for loop for y in those kind of different operations. If it is not in, we're gonna put it inside. Yeah, because we need to check all the numbers. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it works. I think it is still okay. So for the time complexity, as we used for I in range, so this is ON time. Even we use another for loop, nested for loop, but there are only 3 operations, so we just call it ON. And for the queue, basically, this is ON. N is the length of the nums. It is 1000. And basically for this weighted set, we can put the numbers inside the weighted set, but it is limited to 0 to 1000. Yeah. So for the queue, we put a start value. So this start is just coming from 0 to 1000. Yeah. So it means there gonna be only 1000 numbers can put it inside the queue or the weighted set. Yeah. But for nums length, for each of the value, for example, if the value is 1 or 2, for each of the value, so how many different operations? It is ON. So the time complexity is 1000 times 1000. So I'm gonna call it n squared. Yeah, because this number is limited to 1000, and the length is also 1000. Or you're gonna call it m times n. So that's gonna be the time complexity. Yeah, even I put a step inside the queue, but it will have no influence to the time complexity, because for each of the step, basically, this start is also fixed. So we only need to check with this start, because there are 1000 different combinations of the start, and the length of the nums is also 1000. I mean, for each of the start, we're gonna try 1000 different cases. Yeah, as we use the weighted set, so there are only 1000 times 1000 different combinations. So the time complexity would be n times m. Thank you for watching. See you next time.